Okay, so about a couple of months ago, I stumbled across CryptoKitties. And basically, in CryptoKitties, you can buy any immutable, one-of-a-kind e-kitty with Ether. So it was basically like a dream come true for me because I'm very much a cat person. And basically, because it's on the blockchain and it's a decentralized application, these CryptoKitties are immutable. So CryptoKitties is a dApp, much like the 1,200 others that are out right now on the Ethereum blockchain. So what's the difference exactly between a centralized web app and a decentralized application? So there's a lot of differences between the structure actually. So in a traditional web app, we start with the client. So the user is going to submit a request to the client, and then that request is going to pass over the internet and onto the web server. So the web server is going to just manage all the requests, organize them, and then it's just going to forward them onto the application server where most of the meat of the action happens. So in the application server, you're going to process all the requests, and then you're going to actually complete and do the actions that the user requested. And so sometimes like the user will request a query from the backend database, so maybe the application server will do that also, and then it'll push all of the results from the actions back to the client, and then the user will be able to see the response and all the new information pop up on their screen. So the differences actually are pretty subtle here between the structure of a dApp and a structure of the web app. So in a dApp, you will also start with the client interface. So the user is also just going to submit a request to whatever interface they're using, and then that's going to pass through the client API. The client API is just going to do the same thing as what the web server does. It's just going to manage all of the requests and then forwards them to the blockchain client. So the blockchain client is kind of like a node, and basically what it's going to do is, according to the request that user submitted, it's going to call a method from the smart contract on which the dApp is built. And then afterwards, on the blockchain network, there's going to be a transaction that passes, and then that's going to be able to process and actually execute the code, and then the new information is going to pop up to the user at the user event. Okay, so since the smart contract is basically like the brunt of what a dApp is made out of, I'm just going to focus on those, and then we're going to break down a pretty simple smart contract here. So with every single smart contract, it's basically a combination of the code, so in other words, the functions of the smart contract, and the data, which is the state of the smart contract. And all of that is on an address on the Ethereum network. So usually when you start writing, well, all of the time, when you start writing a smart contract, you're going to start with telling the compiler what version of Solidity it's running on. So in this case, we're going to start with the notation of prime of Solidity. You're going to do like an arrow towards the top, and then you're going to tell them what version of Solidity it is. After that, you're going to just open your contract, and you're going to name it. So this one's just called simple storage. And then right after that, you're going to immediately just declare all of your variables. So here we have an unsigned integer that is called stored data. So the difference between an unsigned integer and a signed integer is basically just that an unsigned integer needs to be positive all the time. And also, if you don't specify the size of the integer, it will default to 256 bits. Okay, so after that, we're just gonna go directly into two functions. So the first one is the function set UNX public. So in this function, you're just gonna set a public value for the integer stored data. So whatever data you want, you're just gonna set it that way. And then basically you can think of this as a slot in the database. So the user is just gonna interact with that function, and then that function is gonna alter the state of the data. And then afterwards, you have the function get, which is going to retrieve the data and then return it. Okay, so this is a more complicated one, and this one is actually just a pretty simple smart contract for a token. So we start again with the same thing. You're just going to specify the version of Solidity that it's running on, and then afterwards you're going to open the contract coin. You're going to specify and declare the variable address of the minter who's going to issue all of the coins. And then afterwards, we have a mapping. So a mapping is actually kind of a more complex variable. Basically what it's going to do is it's going to map a key to a value. So you can kind of think of this as an array on steroids, where you're kind of just going to take a key. The key can be whatever string, whatever data type you want, actually. And then you're going to hash that and turn it into any string of fixed size. And then after that, you're going to use that hash code as the index in your array. So in this case, you're going to map the address to the public balance of any user. So the next thing we have is an event. So this event is going to be fired off by one of the functions here, the function send here. So when the function send has been called, it's going to fire off that event. So basically, when you have transactions on a blockchain, there's actually kind of like a receipt under the transaction, and inside that receipt, you're going to have just like some logs, and in those logs, you're going to see all of the events that were fired by functions on smart contracts. And then after that, we have the function coin. So this function is called coin, which is the same name as the original contract. And that's actually really important because that shows you that this function is a special function. It's a constructor. And what that means is that the constructor is only going to run once in the entire existence of the smart contract. And it's only going to run when the smart contract is created. So that means that you can use constructor functions to permanently store the address of the creator of the smart contract. So in this case, since we want the minter to only be the person who has created the smart contract, we're going to store the minter's address. So in this case, under we have minter equals message.sender. So the message.sender is the user who's interacting with that specific function, who's calling that function, right? So basically, since the constructor can only be called once, when the contract is created, that means that the person who calls that function can only be the creator. So that means that the minter is basically locked to the creator's address. Okay. After that, we have the function mint, and it's going to take in two parameters. You're going to take in the receiver's address and also the amount of tokens that you're going to issue. So after that, under that function, we have an if statement that states that if the message sender, the person who's interacting with that function specifically, is not the minter, then you're just going to stop the function right away. You're not going to let them issue coins. And then if not, then you're just going to add the balance that, add the amount that you want to the balance of the receiver. And then lastly, the last function is a send function. So it's a function that allows you to send and exchange tokens between two users and not between the contract creator and the user. So the first one, the first if statement tells you that if the balance of the person who's interacting with that function specifically is less than the amount that they want to send. So basically, they don't have enough money. So you don't want them to be able to send more money than they actually have. So you're just going to stop the function right there if this condition is filled. So if not, then you're just going to take away the amount that you want to send from the balance of the sender, and then you're going to add that same amount to the balance of the receiver. And then after that, in the end, it's going to emit the event that the amount of money was sent. So from the receiver to the, from the sender to the receiver, and also the amount of tokens that were sent. Okay, so I'm just gonna go into mappings in a little bit more detail now. So basically, like I said before, you can kind of think of mappings as a hash table on a very simple level. So basically, in a hash table, it's very similar to an array, except that instead of having like an index and then a value, so basically arrays are just lists of data, and then for each value you're going to have an index for each one. So for example, for the value Ramy, you're going to have 0. For the value Zhang, you're going to have the index 1, so 0, 1, 2, 3, and then you're going to call the index, and then that's going to give you the value associated with that index. So the difference between a hash table and an array is that instead of having an index, you're going to call the key associated with the value, and then that's going to give you the value really fast. So basically what happens is that you're going to take a key. So for example, it can be a name, it can be whatever data type you want. So in this case, it's a string. You're going to hash the key. So a hash function is a function where you take in data of any length, and then you convert it to data of fixed length. So your data of fixed length that comes out from it is your hash code. And then because that is secure, you're going to map that hash code to whatever data you want. And so that's how the hash table will work, and that's also how mappings work. Okay, so this is like a hello world type dApp that I did as like my first project. So I'm just going to go through that really quick. So this is the folder that you'll see. I'm using the Truckle framework to do it, and it helps you just organize everything that you need for your dApp really easily. So we have a couple of folders here. So I'm just going to go into the app folder first. And then in here we have just all of the front end stuff. So you have your HTML, your JavaScripts, and your style sheets. And then after that, in the build, you're going to have the migrations of the smart contracts that you did. So migrations are basically just immutable versions of the smart contracts that allow you to track like when a contract has been deployed already. And then in the folder of contracts, we have the migration contract, which is the contract created by Trouble to help you migrate them, and then the voting contract itself, which is the smart contract where you can actually like do all of the things that your dApp needs to do. And then lastly, there's more migrations. And then this is what it looked like. You have, I already kind of played with it already, so there's some votes on it. But basically, you can write down the person that you want to vote for, click vote, and then the vote submitted. And then you have to wait a while since it is on like a live blockchain. It's a test one. I use Robston, but you're gonna have to wait a bit, and then the vote is implemented and incremented. So why dApps instead of just normal decentralized applications? The reason is because dApps never die. So from the moment the contract creator creates the contract and deploys it, and then the dApp is on the blockchain, that means that no other third-party organization or no other organization or people at all will be able to take that dApp down. So for example, this would be really good for organizations like WikiLeaks, where they publicize like pretty sensitive information that governments may not want to have on the internet. But then if they use a dApp version, then they would be able to always keep their data like safely up there, and then anyone will always be able to access it no matter what like the government tries to do to shut it down. However, there's still a couple of issues that we have with dApps. For example, when CryptoKitties was like at the height of its popularity, it pretty much just slowed the entire Ethereum network down because so many people wanted cats. So that's an issue that's probably still one that the entire blockchain space as a whole really needs to address and hasn't been fully addressed yet. So I'm really looking forward to what this space has in potential for the future, and I'm hoping to play a good role.